Today we're going to look at lesson 6-1, which is primarily on inverse variation. This entire unit deals with rational functions, and inverse variation is a rational function because it can be expressed as a fraction. So, inverse variation can be represented this way, and as we go through this, it'll make more sense. But for right now, there are three different ways that you can express something with inverse variation. If y is inversely proportional to x, it always has a constant of variation. So what you'll see in each of these three equations is this k here, here, and here. That's called your constant of variation. It always stays the same. It's like slope in a linear equation where you have y equals mx plus b. Slope in those linear equations represents the change of y to x. So the constant of variation here in inverse variation represents that constant of variation between x and y. So if you are told that two variables are inversely related, typically I will write it this way. So this is the one that you should be focused on the most. I never use this one. Well, I shouldn't say never. I rarely ever use x equals k over y. And where do they get all three of these? The constant of variation in inverse variation is found by taking x times y. And typically we like our equations solved for y if we're going to graph them. So if I take this equation and solve it for y, I would divide both sides by x, and I would get y equals k over x. So I will use this equation when graphing, and I will use this equation oftentimes when determining if a group of values are inversely or directly related, or if I'm finding the constant of variation, I might actually use this equation here. Then we're going to look at something called joint variation, and it's a relation where one variable varies directly with respect to two or more. So direct variation is just a form, and you might want to highlight that. It's just a form of direct variation. What does that look like? Typically, it's going to be y varies, and then you're going to have the constant of variation on the right. Y varies jointly, meaning you're going to have that constant of variation multiplied by several other variables, maybe an x and a z. You'll notice the difference between inverse and joint variation is when the equations are solved for y, you'll see that the constant of variation is always in the numerator. If I turn this into a fraction, it'd be kxz all over 1. So you'll notice that k is always in the numerator. But with inverse variation, the variable that y is inversely related to is in the denominator. With joint, which is a form of direct variation, notice that they are directly across from each other. The x and the z and the y are directly across from each other. So joint variation just combines direct variation with more than one variable, and it will always be multiplication over here on this other side. These are just some examples. X varies jointly as, I don't know why they've got another x there. That has to be wrong. So it's probably x varies jointly as y and z. And then 8 would be your constant of variation. T varies jointly as p and v. K here is your constant of variation. We don't know what it is. All right, so let's look at some combinations of these together. So the first expression that we have here is y varies jointly with x or z varies jointly with x and y. So if I were you, I would highlight the varies. That clearly is not my highlighter. I would highlight the part that says varies jointly, varies inversely, varies directly. Because what's going to happen is that's where your equal sign is going to go. So my equal sign is going to go here. This is going to go to the left of my equal sign, so I have z equals. Always directly across is going to be your constant of variation, right? And then because it said varies jointly, I know that on the other side here, based upon what we talked about up here, varies jointly means that the other variables that are related to z are going to be multiplied together. Well, the other variables that are related jointly to z are x and y. So we're just going to multiply these right here together, and they go on the other side of the equation. That's it. So let's look at another one. So for the next one, it says z varies jointly. So there's that varies jointly again. So I know that my equal sign is going to go here, and z is going to be on the left-hand side. So z equals, and then varies jointly with x and y and inversely with w. Well, we'll deal with this in a minute. So it varies jointly with x and y. So I have to put my constant of variation in, so it's always on the other side. And then the x and y is joint variation. So remember, joint variation, that means that this is going to be directly across from z, multiplied together. So it looks very similar to that first one that we did. But it went on to say, and inversely. So I need to highlight that. It's got two different variations going on here. As soon as I see the inversely, I am going to put a division bar, and this, whatever follows this, is going to go in the denominator, because w is inversely proportional to z. So w needs to go in that denominator, and so it would go down here. So it takes a little bit of getting used to. So again, z varies jointly as x and y, or with x and y, so they go directly across in the numerator. And it should say z varies inversely as w. And so that w goes in the denominator. 100% of the time, k, constant of variation, goes in the numerator. Why don't you try the last one on your own? Pause the video, see if you can get that last one on your own, and then restart the video. So the parts of this that are important is that v varies directly. Well, varies directly we actually haven't talked about yet, but I know that my equal sign is going to go right here, and z is going to go to the left of it. So z equals, I do know that my constant of variation is going to go on the other side, and it says varies directly. Well, remember, direct variation and joint variation are the same thing, but this doesn't say varies jointly with x because it's only a single variable x. If it's more than one variable, like x and y, then it's going to say varies jointly. So it just is varies directly with x, so x goes directly across over here, so it's in the numerator, and inversely, right here, with the product of w and y. So in the denominator, because inverse variation goes in the denominator, the product of w and y would look like this. So give yourself a pat on the back if you got that correct. Good job. All right, so the next section we're going to identify, given a table of values, whether a group of ordered pairs are inverse or direct variation. Or it could be neither. So I'm going to make these bigger, and what you're going to do, maybe straighten it out, and what you're going to do is you're going to look at the product or the quotient of x to y. So if you go back and look up at the top of your notes, if we have direct variation, so direct variation, remember, y was equal to k times x. So if I were to solve that for k, because I'm interested in the constant of variation in these particular two examples, so if I solve this equation for k, it would equal k is equal to y divided by x. If I have inverse variation, so I'm going to squeeze it in here, inverse variation. Then remember, inverse variation was y equals k over x. If I solve this equation for k, I would multiply both sides by x, and I would get k equals xy. So if I'm looking at a group of ordered pairs, I'm going to divide their y by their x's, or multiply the x to the y. And I'm looking for the same constant number every time, because if these right here are directly related or inversely related, when I divide y by x, y by x, or multiply these, I should get the same constant of variation. Let's see which it is. So if I go to my calculator and I take 8 and divide it by 0.2, that's my y divided by 0.2, I get 40. Okay, and then next if I take, I'm going to switch colors here. Next if I take 20 and divide it by 0.5, I also get 40. I can't just assume that that's direct variation because I have to test every single one. And so then I'm going to switch colors. 40 divided by its x, which is 1. So clearly that's 40. And then finally 60 divided by 1.5. Don't assume, make sure you test it all. So I'm going to plug in 60 divided by 1.5 into my calculator, and sure enough I get 40. So the very first time I tested, I just happened to test it for direct variation. It worked. So that means that right here that tells me that k is equal to 40. And because we divided, it is direct variation. Look at my nice, neat handwriting. It's terrible. They also asked to write the function model. That means the y equals. So I've got y equals k, and remember with direct variation, it looks like this right here, y equals k times x. So y equals k times x. Well, I know that my k is 40 times x. So this is my general formula, or what they like to call the function model. All right, so let's look at B. So for B, I want you to try dividing. First, take your y and divide it by your x. If you don't get, like let's say that you take 40 divided by 0.2, and it doesn't, and well, you'll get a value. So let's say 40 divided by 0.2. So you get 200. If when you divide 16 by 0.5, if you don't also get 200, you don't have to test every one, right? So then you would go to multiplication. So pause the video, divide y by x. If that doesn't work, multiply x by y. If that doesn't work, then it's neither direct nor inverse variation. So pause the video, figure it out, restart the video. Okay, so hopefully if you pause the video, you determined that if you multiply, if you divided, you didn't get the same thing, because we already divided 40 by 0.2 and I told you that was 200. So 16 divided by 0.5 is 16 divided by 0.5, I didn't get the right answer, is 32. So because those don't agree, I went and I multiplied. So I did, let me say, so I did multiplication through here. So I just multiplied, equals. So 0.2 times 40 was equal to 8. Half of 16 is 8. That's 0.5 times 16. 1 times 8 is 8. And 2 times 4 is 8. So that means that since we are multiplying, it is inverse variation. That looks so much better. Well, it started out good. Inverse variation, I know that my k is equal to 8. Now, inverse variation is y equals k over x. So now that I know my k, my function model is 8 over x. So pat yourself on the back if you did that correctly. All right, next page. So part C, I want you to do the same thing. Pause the video, divide and multiply, and see if you come up with direct, indirect, or neither. All right, so if I divide, so I'm going to do a list here of y divided by x equals k. So I get for that one, 40 divided by 0.5 is 80. And then 12 divided by 1.2 is 10. So right there, those aren't the same. So I just stopped and said it fails. Okay, so then I'm going to go to x times y equals k. All right, so then 0.5 times 40 is 20. And then 1.2 times 12 is 14.4. So that one also fails. Since both methods fail, then your answer is neither. And you cannot write a function model when it is neither, at least right now. Okay, so then let's look at example 2. So in example 2, they tell you that x and y varies inversely. So that's important. You want to highlight that. So as soon as I see that x and y varies inversely, immediately I write y equals k over x. That's my very first step. Then, so that's step 1. And a lot of you are going to skip this and you're going to miss part of the question. So it says, what function models the inverse variation? Well, I have to find the constant of variation. So what they have done is they have given me an entire set of ordered pairs. I have both an x and a y value. So in step 2, I'm going to substitute into this general function right here, the one where I don't know my k. I'm going to put the x in for the x and the y in for the y. Now you could have multiplied these to get 2 together knowing that it was inverse variation. So that is a possibility. So that's an alternative. You could definitely do it that way. Either way, it doesn't matter. So then for my y, I've got -3 and then equals k over, that's a k, over my x is 2. So if I'm to solve for k, this happens to be a proportion, so I'm going to cross multiply and solve. I get a value, k is equal to -6. So my third step is to actually rewrite this function right here, but instead of the k, I'm going to put in the -6. So I have y equals the -6 divided by x. And so this is the function that they were looking for. Now, oftentimes in this type of question, they'll give you this full ordered pair, and then they'll say, suppose x and y varies inversely, and x equals 2 when y equals -3. Then they'll say, find x when y is 6. So it's important that you know this particular step in order to a problem like that. So that's a little step up. All right, so part 3 says, what does the graph of the function look like? Well, you have to have the correct function. So I'm going to change my pointer to my laser pointer. So right here, we're going to graph this rational function. You could substitute in values for x to find y. And I would only substitute values in for x that divide evenly into -6. I want you to ask yourself, what values could x never be? Remember, this is a fraction. What part of the fraction can never be 0? This denominator right here. The numerator can be 0, that's okay. But if the denominator is 0, that function is undefined. So right here, x cannot equal 0 because it causes an undefined function. And what's going to happen is that becomes what's called a vertical asymptote. So I'm going to put right here on my graph this dashed line, because it's not really part of the graph, and label it as x equals 0. How do I know it's x equals 0? It's a vertical line going through the x-axis at 0, so it's going through the x-axis, so x equals 0. Okay, so then I'm going to set up a table of values over here to the left. So I've got x, y, and as I told you, I'm only going to choose values for x that divide into -6. So on my graph, the biggest number that divides into -6 xy's that will fit on my graph is -6 itself. So I'm going to choose -6. And then as I go across this graph right here, -5 won't work, -4 won't work, -3 will work. So I'm going to choose my next value to be -3. Then negative 2, that divides into negative 6 as well. So I'm going to choose negative 2. The more points I have, the better my graph is going to look. And then negative 1 is also going to work to negative 1. Remember, we can't choose 0. And so then on the other side, I'm going to choose the same values because those are all going to divide into 6, negative 6 as well. So on the other side, I'm going to choose positive 1, positive 2, positive 3, and positive 6. So if I throw all of these values right here into the function here, we get the following. So negative 6 divided by negative 6 is positive 1. Negative 6 divided by negative 3 is positive 2. Negative 6 divided by negative 2, positive 3. Negative 6 divided by negative 1, positive 6. Negative 6 divided by 1, negative 6. Negative 6 divided by 2, negative 3. Negative 6 divided by 3 is negative 2. And negative 6 divided by 6 is negative 1. So I'm going to plot all those ordered pairs. So negative 6, positive 1, negative 3, positive 2, negative 2, positive 3, and then negative 1, positive 6. So then it creates this curve right here. All right, and then on the other side, I've got positive 1, negative 6, 2, negative 3, 3, negative 2, 6, negative 1. And so we get this curve here. Okay, now one of the things that we're going to start to explore in this particular section is domain and range. Now, because x is our domain and x could not equal 0, our domain here, and you can see it here as I'm going from left to right, I've got a graph here. So I have a domain, I have to jump over this fence, so that's a break in my domain, and I keep going, I have a graph. So my domain would equal negative infinity until we hit the fence right here. So that's going to be a break, so that'll be 0. Then I have to union that with 0 to positive infinity. Sorry, I ran into that. So this is my domain right here. Then my range, it looks like I have a graph all the way along here. The question is, could the value for this graph ever be 0? And in this particular unit, you're going to find out how to determine if there's a horizontal asymptote, but we're not going to do that yet. You're going to find out that the value of this fraction could never actually be 0. So this actually is our range as well, but we'll get more into that later. All right, let's look at the last part. The last part is kind of what I was hinting to earlier. It says, what is y when x is negative 5? So you need to take this equation, you must have the general equation, and use that and substitute in this value for x. So I've got y equals negative 6, and instead of x, we're putting in negative 5. So that means that y is going to equal positive 6/5. Do not give me a decimal. I don't even care if the answer says a decimal. I believe online in some of these, the answer will give you a decimal. I want a fraction, fully reduced fraction. Don't give me the decimal. So if you give me a decimal on your homework, I'm going to know that you didn't listen to me or you just copied the homework online. And I will dock you points. So fractions. All right. Hopefully that's clear. Next page. All right, so in this next page, we're going to look at word problems. That's your favorite, I know. So example 3 has 2 parts to it. And this particular one says, a recent hurricane left debris around the neighborhoods near your school. The table below shows the time t in minutes that it takes a group of n students to remove the debris from an average size yard. Y'all would know nothing about that, right? All right. Sometimes I think we have more debris from storms versus hurricanes. All right, so this is going to be our x. Well, typically, I guess the way they're writing it, this is going to be our x and this is going to be our y, because who affects what? The number of students is going to affect the amount of time that it takes to clear the yard. So our number of students is going to be our independent variable, and our time is actually going to be our dependent variable. So the first question is, do we know if it's inverse variation or direct variation? So let's start with inverse variation. So I'm going to start with just seeing if I multiply x times y together, do I get k? So, and the only reason why I started with that is I happen to notice that as I multiply 1 times 225, I get 225. I also happen to recognize, as I was looking at this information, that 3 times 75 is also 225. Guess what 4 times 45 is? And 14 times 16, you are going to have to actually change, whoops, hang on, didn't mean to write that line. You're actually going to have to change 14 times 16 because Miss Jean Adams has that written wrong. 14 times 16 is 224. So since that bothers me that it's not correct, we're going to change this to 15 and change this to 15. Now they all actually multiply to give you 225. And so therefore, our constant of variation is going to equal 225. That's important because the first question says, what function models the time needed to clear the debris from an average size yard relative to the number of students who do the work? So we just found up here what our k was. So then we're going to use y equals, because it is inverse variation, we're going to do y equals k over x. So y equals, we found our k to be 225 over x. I prefer this for our purposes here in this question. Okay, so then part B says, how many students should there be to clear the debris from an average size yard in at most 25 minutes? So 25 minutes is going to be our x. So this right here is our x. And so we don't know y. So y equals 225 divided by, and they just gave us our x as 25. So let's go ahead and divide those out. 225 divided by 25, and we get 9. So y is equal to 9. All right, so you're going to want to write that out as therefore. There should be 9 students. Now you are not going to see in your answer answering the question in a complete sentence. So again, if you don't answer the question in a complete sentence, I will probably know that you copied offline or you weren't paying attention to the details in this video. So pay attention to details. All right, so example 4, we're going to use combined variation. That means we're going to have more than one variation going on here. So let's go ahead and read what they're talking about. The number of bags of mulch you need to cover a planting area varies jointly. So that's important. So if I were you, I would stop and highlight that varies jointly. What goes to the left? So the left is the number of bags of mulch you need to cover a planting area. So I immediately would be thinking, okay, to the left of varies jointly is number of bags of mulch. So I'm going to probably write this out in words. Number of bags of mulch equals. And then remember, varies jointly means that we're going to have a k over here on the other side. So there'll be a k over here. And then it's going to directly across from that be more than one thing being multiplied together. So let's see what follows varies jointly. With the area to be mulched, A in square feet, and the depth of the mulch, D in feet. So this is going to be A times D depth. I'm only using A and D because they physically gave that to me as a variable. Now I'm probably going to make number of bags of mulch be B, since we haven't used that one yet. Okay, let's see what else they tell us. If you need 10 bags to mulch 120 feet squared to a depth of 3 inches, how many bags do you need to mulch 200 square feet to a depth of 4 inches? So here's what they've done. We're going to write out our general formula. So I'm going to let this be B, and I know that looks like a 6. It's a B, equals K, A, D, CAD. So this is step 1. That's my general formula. I have to find what K is. I've got to find this value here. So step 2 is actually to find my constant of variation. And what they have done is they've given you all 3 of these variables. So they've given you one full triple ordered pair, if you will. So they did that here, right here. Right? So I'm going to put 10 bags, so the 10 goes in for B, equals K times my A and my D. Well, my A is my area, 120. I'm going to squeeze that in there, to a depth D of 3 inches. So I'm going to solve that. So I have 10 is equal to 360K. I'm going to divide both sides by 360. So I get 10 over 360, which reduces to my K is going to be 1 over 36. So my K is a fraction. So then step 3, I'm going to rewrite my general formula, and this part is important. So I've got B equals, instead of K, I have 1/36, and then I have times AD. So technically the AD is in the numerator. So if you want to, you could rewrite that. So it's B equals A times D over 36. I would accept either one of those as your general formula. So then follows this. They give you a partial triple ordered pair. How many bags do you need? So we're not going to know B. To mulch 200 square feet, so that's going to go in for A, to a depth of 4 inches, that's going to go in for D. So then my part 4 is going to be B equals, okay, so for my A, they gave me 200 square feet, so I'm going to squeeze that in there, 200. And then for my D, my depth is 4 inches, so that's going to go in there. And so you're welcome to use your calculator, but if I put in, let's see, 200 times 4, and then divide by 36, I get a decimal. It's 22.22222. So what I want you to do is I want you to hit math, enter, enter, and you get 200 ninths. Well, in this particular case, it's a real life problem. And I know from the decimal that I have 22 whole bags. So B is equal to 22 whole bags. And so what I'm going to do is I'm going to take my answer of 200 times 4 divided by 36. And I'm going to subtract the 22 from that because I just want the 0.2 repeating fraction. I'm going to turn that into 2 ninths. Now, the question is, can I go to Home Depot and buy 2 ninths of a bag of mulch? Nope. They're going to look at you like you're crazy. So I can't buy 22 bags. It won't be enough. So I'm going to have to buy 23 bags. So, therefore, so this is part, whoops, I want 5. Part 5, therefore, you will need 23 bags of mulch. Okay, on this last page of notes, we're just going to put it all together. So example 5, you have to find the constant of variation and then write an equation that can be used to solve for the missing values. So I need you to listen. There are parts that you must have for this. You have got to write the general equation. So y equals k over x, or y equals k times x. You have to write that general equation with the actual value for k in there. I have to see that general function model. And then you can use that function model to solve for the missing piece. All right, so there's two parts to these answers. So, step one. So this one says that if z varies jointly, so varies jointly, remember, means it's direct variation. It's going to be z on the left. Oops, sorry about that. Let's try that again. Z on the left equals k, and then directly across from z is going to go more than one thing be multiplied together, because that's joint variation. It's just like direct. So the x and y are going to go here. But I don't know my k yet. So then next they're going to give you a full, in this case, a full triple order pair, an x, a y, and a z value, which they do. Here's your x, your y, and your z. We have to have all three in order to find k. So then part two is plugging those values in to the equation we just wrote. So z is 120 equals k times our x is 3 and our y is 5. So I get 120 equals 15k, divide by 15, divide by 15, and so k is equal to 8. Now, this is the part you can't skip, and this is the part that at least 50% of you are going to try to skip. I need to see you write it as z equals. I need that 8 in there, and then the xy. This is one of the things that they are physically looking for, right here. It says, write an equation, okay? Then they continue on. Find x if z is 35 and y is 7. So we have, that's just part one to our answer. So then the fourth part is we're going to use this equation right here and plug in our partial values and find the one that's missing. So I know that my z is 35. And so that equals 8 times, I don't know my x, but my y is 7. So I get 35 is equal to 8 times 7 is 56, x, then divide by 56. And so my x value is 35 divided by 56. You're going to hit math, enter, enter, and you get 5/8. Please do not give me the decimal. 5/8 is the most correct answer. So this is the second part to that solution. So there's two parts there. I must see both or you're going to lose points. Okay, so you try part B on your own and see if you can do that by yourself. So pause the video, do part B, and restart it. Okay, so here we've got varies inversely. So this is not jointly. So as soon as I see varies inversely, whoops, keep forgetting. So here's step one. And then y varies inversely. So I know something's going in the denominator with the square of x. So you have to square x. So x squared. All right, so then they're going to give you a full x and y value, which they do right here. Right? So I've got my y is 7 over 15. Isn't that fun? Times or equals k over, and then I'm going to square my x, which is 3. And so if I were you, I would solve this as a proportion. So I've got 15k is equal to, and then this is 9 times 7 is 63. And so then divide by 15. And you're going to get a fraction. So 63 divided by 15 is 21 fifths. So 21 fifths. I do not want the decimal. All right. So then part 3, they actually want the model. So that model is going to look a little weird because k is a fraction. You can't have a fraction and a fraction. So this part of the k is going to go in the numerator, and this part of the k will go in the denominator. And so you are going to end up with y equals 21 over 5x squared. So that's your general model. They're looking for that. And then part 4, find y if x is 5. So y is equal to 21 over 5 squared, and we're going to put in 5 for that. And nothing here is going to reduce. So we've got at least, nope, nothing's going to reduce. So we have y equals 21 over 225. Oops, I meant 125, not 225. 125. Whoop, there you go. Okay, so those are the two parts to that one. Then the last question is combining quite a few things here. So we've got gravitational potential energy, PE, is a measure of energy. So PE is going to be considered one ordered or one variable. It's not P times E, it's just one variable. So PE varies directly, so that's important. So I'm going to highlight the varies directly part. So I know that for my formula, I'm going to have PE equals, and then I'm going to have a K directly across, with an object's mass m and its height in meters above the ground. So it actually should have said varies jointly with an object's mass and its height. And the reason why I say that is because it is varying jointly with, let me get my little hand back here, it's varying directly with more than one thing. And actually they've given you the whole thing here because they said the constant of variation is going to be gravity. So they're letting K be G in this sense, and then M times H. So we wrote PE K M times H. They wrote G M H. It doesn't matter. So this is step 1. Okay. So then step 2, use the gravitational constant of 9.8 meters per second and joules for PE. So PE is that measure of energy, and so this is kilograms times meters squared per second. So that's just your unit of measure. Okay, so they told us what our constant of variation is. So that's our second step. So they told us PE equals, they told us to use 9.8. So I'm going to do 9.8 mH. Okay. Now, I want to make sure that I get my, my units of measure should actually come out to be, hopefully, this, because our measure of energy is reading as joules. So we should end up with kilograms times meters squared over second. So in this particular one, I am going to show all the units of measure. So then step 3. The question says, how much potential energy would a 41 kilogram diver have standing on a 10 meter diving platform? So the mass is 41 kilograms and the height is 10 meters. So here we go. It's actually easier than what it looks. They're just trying to make it look complicated. So PE is equal to, and I think I might run out of room. So let me write this down here a little bit. So I'm going to go down here. So PE is equal to 9.8, and they gave me the 9.8 as meters per second. Now I'm going to write that as a fraction for a reason. You'll see why. Times, and then my mass, they said, was 41 kilograms. I'm going to put that over 1 times my height was 10 meters over 1. So note here that meters times meters is going to be meters squared. There's the meter squared. Kilograms, there's my kilograms. And then seconds is the only one left in the bottom, so there's my seconds. So all I have to do is take 9.8 times 41 times 10. Since there's a decimal in the original problem, if you get a decimal answer, you're welcome to keep it. So 9.8 times 41 times 10. And I do not get a decimal, so I get PE, PE is equal to 4,018 kilograms times meters squared over seconds. So this part right here represents a joule. So we can rewrite our answer as PE equals 4,018 joules. So therefore, the potential energy would be 4,018, I guess capital, joules. And that's it. So this was an introduction to inverse variation. We will do more with direct variation in our next lesson. So if you have questions, don't hesitate to text.